Hello guys, welcome to Easy Math with Tammy. So if you haven't subscribed to this channel yet, ensure that you subscribe, like and share so you can see more of content like this. So today we'll be looking at the problem on the screen, which is an improper integral. But now we'll be solving this problem using comparison theorem. So we'll be using comparison theorem to solve this. And then basically what it says just that you look for a function that's bigger than this, right? And then you work with that function basically, because this to solve this is kind of cumbersome, kind of difficult. But if you look for a function such that the function is bigger than the integrand, right, and then you can easily integrate that, then it makes sense, and then it's kind of like easier for you to work with, right? So what we're gonna do now is that we're gonna look for something, a function that is bigger than the integrand, right, or equal to or bigger than the integrand, and then we work with the function. So now we know that our sign is bounded. Okay, so our sign is bounded by 1, right? So which implies that I can have 1 plus 1, right, root x, and this is equal to 2 root x. So now we have that this guy here is bigger or smaller than this guy here. So with that we can easily integrate our 2 over root x, which is much more easier compared to integrating 1 plus sine squared x over root x. Sine x trig function is bounded by 1, right? So it makes a lot of sense, right? So that's why we have 1 plus 1, and that gives us 2. So now we can just integrate that. So that will be 2 root x dx, right? So and then we apply just the same way we worked on the improper integral, right? So this is gonna be 1 to t, and this is 2 over root x, right, and root x dx. So this is 2, you can take that out, I'll just have this dx. So now we see that we can actually easily integrate this, and then everything comes out just exactly what we want, right? So this is going to be, if you integrate that, alright, so that's just going to be 2 root x, right, and then you put the limit in, and that's going to be 4 limit t goes to infinity, and that's root t minus 1. And then if you substitute our t here, we can see that everything goes to infinity. So with that goes to infinity. So that tells us that our original integral goes to infinity, and that implies diverges. So that tells us that this diverges. So you can see this is kind of like pretty easier. Instead of like you have to integrate that the integrand, and then you might get a little bit confused. So if you apply this theorem, this comparison theorem here, it makes your work a little bit easier, and then you can get exactly what you want. Because what we need is to check if this integral converges to diverges, and then straight up, because we compare with a function that is easier to integrate, and then we get the right answer. So that's how you solve an improper integral using comparative theorem. And then if you have anything, you can put it on the comment, and then I'll check it out. Then I see you on the next one. Bye for now.